This is CS1101, lecture 9.1. We're discussing arrays, and we're going to continue to discuss arrays for the next couple of lectures. So consider this problem. Someone attempts to type in 7 integers in a row, and after they're done typing in each integer, we want to print out the 7 integers in reverse order, starting with the most recent one typed in, then so forth, back to the first number that they typed. How will we go about this programmatically? Well, we're going to have probably some sort of a for loop or a while loop, just depending on how we do it. Probably a for loop, since this is exactly 7 numbers. So we're going to use some sort of a counting loop instead of an event loop. And we would 7 times prompt a user to type in an integer. So far, so good. Then once the user has finished typing in integers, we will print out the most recent integer, because we've probably stored that in a variable. So that's not that hard. We can print out 53. But wait, how are we going to print out 46? Because whatever we had coded into our loop, we executed and stored the most recent number that they typed into a variable. But we would also have to have a dedicated variable for 46 and one for 37, one for each of the numbers that they typed in. So we would have to declare 7 variables to be able to perform this operation. And then I guess we would have to have some sort of an if statement inside of the loop to decide, based on which iteration through the loop we're at, which variable to use to store the current number. You see the problem? What we really want to do is remember all the numbers that the user typed in. However, to remember all those numbers, we're going to have a number of variables equal to the number of integers the user types. We might be able to hack this together with 7 variables in the situation where we know that the user will type in 7 integers. But what if this was a situation where we don't know how many integers the user is going to type? Sort of like a while loop where we are, waiting for them to type -1 as a sentinel to tell us they're done with whatever portion of the program we're currently executing. In that case, we don't know beforehand how many integers they're going to type. How could we possibly have created the right number of variables to be able to store whatever they enter? Think of another problem. Imagine we prompt a user for a number of days. So this is exactly what we talked about. The user is going to tell us how many days they're going to enter temperatures for. So there's no way we could possibly have created enough variables beforehand to be able to store what the user types in. And then we will get however many temperatures that the user says they're going to type. We will get that number of temperatures from the user. And in this case, it's 7. So it'll prompt the user for 7 temperatures, calculate the average, and then tell how many days were above that average. So why is this tricky? First of all, we don't know how many variables we're going to need to be able to store temperatures. Do we really need to store all the temperatures? Yes, because we need to calculate the average over all temperatures, so that means we have to wait till we have all of them typed in. If it was just a matter of calculating the average, we could just sum it together, keep track of how many the user typed in, and then divide. But in this case, we want to get the average and tell how many days were above the average. So after we calculate this average, we want to go back and look and see how many of these were greater than this number. So we really do need to remember all of these numbers that the user typed in. And there's no way to know how many they're going to type, so there's no way to create enough variables to be able to store this data. So how would we handle this? So like we said, we need to look at each input value twice, once to calculate the average, and then once to see how many were above that average. And we don't know how many they're going to type in. So what we're really looking for here, rather than trying to figure out a way to make enough variables to store all the data, we really want one variable that's able to hold however much data we need. This is a very common situation in programming, and we have carefully and sometimes awkwardly avoided this problem up to now because we had not yet dealt with arrays. So every programming language needs a way to handle lots of data. The typical way to solve this is by using arrays. So first of all, an array is an object in Java, and we use them to store collections of data, sometimes very large collections of data. Now, all the data stored in an array must be of the same type, so we can't mix integers and doubles in a single array. If it's a double type array, then everything in the array must be a double. If it's an integer type, everything in the array must be an integer type. And we can declare arrays of object types, so the same thing would be true there. We can't mix integers and objects. So everything in the array must be of the same type. Arrays are objects, and often objects will have built-in methods. This is true of arrays as well, but the number of methods that are built in are small, and often we need helper classes to be able to extend the built-in functions. So thinking of an array as an object in Java is accurate, but sometimes it might be more helpful to think of it as a collection of individual variables. So in reality, we have an object, we're dealing with an object, but an array is a place to store lots of information. And so it can be nice to think of it as many individual variables all clumped together. Now let's look at the syntax for how to declare an array, and it'll become clear why thinking of them as a clumped set of variables is helpful. So in this following line of code, we are building an array with a length of 7. So it'll have 7 spots that can each hold one double value. So the syntax is double, open bracket, close bracket, the name of the array, then you assign it a newly declared double array object. And this is the way to declare an array of length 7 of type double. So now each of the spots in this array would be accessed in the following way. If we wanted the value which was stored in the first location, we would get that using this statement: temperature, bracket, 0, close bracket. Another way we could declare the same array, similar to how we declare any other variable or object, would be to declare, first of all, the variable which is going to hold the reference to our object in memory. So remember, an array is an object. So when we assign the variable called temperature, this object, what we're really doing is we're saying, here's a newly declared double array object, and we're going to store its location inside this variable called temperature. So down here, what we're doing is we're creating the variable called temperature, and we're telling Java, hey, I'm going to store a reference to a double type array in this variable. Then in the next statement, we assign that variable the location of our newly constructed double array object. Now, this is the index 0, 1, 2. That's how we refer to getting values from an array or accessing the value at a particular location. We would be indexing the array. So if I wanted the value in the first position in the array, we would use the index 0. So this is sort of like strings. They're 0-based indexed. So this array has a length of 7, but the max index is 6. That's because we start counting at 0. Now the cool thing is, each of the elements or locations in the array can be used in the program just like variables. For this reason, each individual element of the array can also be referred to or called an indexed variable or a subscripted variable. So an example of using an array element in your program like a variable would be, let's say we wanted to assign the value 32.0 into our temperature array. We would say temperature, and we're going to store it in the 4th location, which would be the 3rd index. So temperature index 3, and then we're assigning it to the value 32.0. So now the value 32.0 is stored inside our array at index 3. Same thing here. We're going to store in temperature index location 6 the value that is stored in temperature index location 3 plus 5. Finally, we can also use them as parameters to, say, the print line method. So we can print out the value stored in temperature index location 6. We can also, and this is a very powerful thing to do, we can also index our array using an integer variable. So we can create an integer variable and choose which index location we want to access or store into via the value stored in that variable. Typically, this is called indirect addressing. So what can we use for the index? We said we can use a variable, and we obviously were using literals when we were typing in 6 or 3. So what can we use as an index? The answer here is any integer expression. So we can put any integer expression we choose into the brackets. But let's put some rules to that. So we can use an integer expression, any integer expression, which means it's going to evaluate to an integer value, but it also must not exceed the maximum index of the array. So just like with strings, we said if we tried to read from index location 7 on a string that only had a length of 4, or index location 7 on a string that had a length of 7, right, because 0 indexing, the max index is 6. In either of those situations, we're trying to read from something that doesn't exist, a location in memory that doesn't exist. So therefore, we're going to get a runtime error. Same thing here. Our index must reference a location in the array that is valid. So when we declared our temperature array, we gave it 7 locations, which means the maximum index is 6. If we attempted to access index 7, we would get a runtime error. So quick rehash on the terminology. First of all, an array is an object that is able to store many values of the same type. We call each of the individual locations an element, and we address those locations using an index. So given an array and an index, we know which element we are attempting to look at. So the typical way to depict an array is a connected group of boxes, with each box being the location of one element. So in this example, we have a 10 element array of type integer, but that means our maximum index is 9 because we start counting from 0 always with arrays. So this is element 0 because it is also index 0. This is element 4 This is element 9. This is how we would talk about an array. It has elements, and it has an index, and if we wanted to talk about this -6, we would say something along the lines of element 6 in the array has the value -6. Element 0 in the array has the value 12. So we've shown the syntax for how to declare a double type array. Now let's look at the general syntax for any type. So we have type, so the type of the variable, followed by open and close brackets. That tells Java we're not going to have a variable of this type, we're going to have a variable that stores a reference to an array of this type. The name of the variable, and then we have to create the array object using the keyword new. So this will allocate memory, and then this generates the number of elements in the array. So this statement on the right hand side of the equal sign creates the object and defines the length of the array. So as an example, if we were going to create an integer array like we looked at on the previous slide, we would have int, that's the type, but we're not just having one integer, we want an array of integers. So we have open and close brackets to tell it that it's an array. The variable name is number. So this variable number is going to store a reference to our array object. And now we need to give it that reference. We need to tell it what the address is of the array object. And so we create a new array object of type integer with 10 elements and store the location of this new object in our variable called number. And now in memory we have this array. Notice that if we declare an integer array, it initializes each value to 0. So when we're talking about the type of an array, we usually refer to that as the base type. The base type of an array can be any type. So that means either primitive or class types. So if you remember, we had a class called point that defined a point in XY space. So if we were to declare an array like this, where we say type is the point, followed by open and close bracket, Java says, okay, I understand what you're saying. You want a variable in which to store the location of an array of point objects. And then we give that variable a name called starPoint, and we assign it a new array object where each element in the array is an object of type point. And there are 5 of those. So 5 elements in this array of type point. The number of elements which the array can hold is the length or the size of the array. So even though the max index may only be 9, the length would be 10 because there are 10 total elements since we start counting at 0. So we mentioned that we can use any integer expression, assuming it does not yield a value which goes beyond the maximum index of the array, to address the elements of the array. Similarly, we can choose how many elements to have in the array using any integer expression that yields a non-negative integer. So here we could use x mod 5 plus 2. That's going to yield a positive integer because x is a type integer variable, and so this would be a valid way to declare an array called data. So we said whenever we declare a new array, it is initialized with a 0 value when we were dealing with type integer. Interestingly, Java will initialize any type of array to a 0 equivalent value. So what that means is if we're dealing with doubles, the initial value of each element will be 0.0. If we're dealing with an array of type Boolean, so each element in the array is a Boolean value, each value will be initialized to false. If we declare the array to be of an object type like string or point, then the array is initialized with each element having the value null. Null means we have not yet assigned a reference to an object to that location in the array. So the general format to be able to access a value or modify a value in a particular element of an array would be the name of the array followed by open bracket and then the integer expression, which will give us the index that we want to access. Much the same, if we want to modify a location, then we have the name of the array, open bracket, and then the integer expression for the index of the element we wish to modify, followed by close bracket, and then we can assign it a value just like we would a variable. Remember, one of the simplest versions of an integer expression would just be an integer literal. So in the following examples, we'll just use literals to address the array or to index the array. In the first statement in our example, we have int open bracket close bracket, so we're creating an integer array. We're calling it number, and we're assigning it a new integer array object with length of 10. Okay. In the next statement, we're going to assign the first element, so that is element 0, the value 27. So here we are using an integer expression to give us the index that we want to modify, and that integer expression is, in this case, just an integer literal. In the next statement, we are going to modify element 3 by setting it equal to -6. So we assign the value -6 to element 3 in our number array. In the next statement, we're going to print the value stored in element 0 to the console. So our first assignment stored the value 27 in element 0. The second assignment stored the value -6 in element 3. Our print line statement would print out the value 27 to the console. Now in this if statement, we would read this: if element 3 in the number array is less than 0, print out element 3 is negative. So element 3 is less than 0, so we would print out element 3 is negative. Here's another example. So we are creating a double type array called result and assigning it a new double array with length 5. Now notice when we create this array, initially each value is 0.0. The blue values are the values that we're going to change in our program. So we are going to modify element 2 to be 3.4 and modify element 4 to be -0.5. But when we create this array, in the very first statement, every location in the array has the value 0.0. Then when we execute the assignment result element 2 equals 3.4, we store the value, we assign the value 3.4 to element 2 in the result array. In the next statement, when we assign the value negative 0.5 to element 4 in the result array, we change the value in the array in element 4 to negative 0.5. So we can read from this array and we can write to this array. It's not like a string where it doesn't change. This is not an immutable object. So we are able to change what is stored in each of these locations and read the value that is stored in each of these locations. Let's look at another example. We can create a Boolean type array, call it test, and we assign it a new Boolean array object with length 6, which means the maximum index is going to be 5. And when it's initialized, when it's first created, each element has the value false. Then when we execute the statement following initialization, and we set element 3 of our test array to true, we change the value from false to true in element 3. So again, we can read from it and we can write to it. So just a little bit on array naming. You may be tempted to, instead of calling an array temperature, calling it temperatures. So using the plural form of the noun. That makes sense, and it's reasonable to think that way, but it's better to use singular names. So you should prefer temperature to temperatures. Using singular forms of words gives the code more readability, which means it's more maintainable long term and it's better self-documented. And as you get more familiar with using arrays, you'll begin to see that even though the array called temperature stores multiple temperatures, each individual access to that array in the program only modifies or reads a single element from the array. So in the program, we're only making use of one temperature in each location where we access the array. So here's a mini exercise to verify your understanding thus far. Pause the video, take a moment, and figure out what the printout will be from this code. So first, we are declaring an integer array called A and assigning it a new integer array object of length 5. Then we are assigning, well, let's draw it out. So A has 5 locations, and in element 1 we are going to store the value 2. But remember, arrays are 0 indexed, so we will store the value 2 in element 1, which is the second element in the array. Then in element 2 we'll store the value 8. Then in element 3 we'll store the value 10. What value is stored here and here? When we create the array, every value is initialized to 0. We only modified the 2 middle values, so both the beginning element 0 and the ending element 4 have a value 0. Alright, so when we execute the print line statement, we will print the value stored in element 3 to the console. So we'll print 10. Then in the following statement, we will multiply the value stored in element 2 times the value stored in element 3. Element 2 is 8. Element 3 is 10. This will print 80. We'll print the value stored in element 0 multiplied by the value stored in element 2. Well, 0 is stored in element 0, so regardless of what we multiply by, it's going to result in 0. Next, we'll print the element 1 plus 2. So we can index an array using any integer expression. So this integer expression is going to evaluate to 3. So index 3 in our array A, that's element 3, which is 10. So we will print 10 yet again. Then in our last statement, it's a bit trickier. So we have our array A, and we are going to index it with the value stored in element 1 of our array. So understand, this is what's happening. We work from inside to outside. We have the integer expression 1, which means this is just the integer 1, as the address or the index to our array A. So this is going to evaluate to the value stored in element 1 of array A. That is the value 2. So we can replace this with the number 2. Then 2 is the index for this access to array A. So we're now accessing element 2, which would be the number 8. So we print out the number 8. We mentioned that since arrays are objects, then there are methods built into the object. There are also properties or fields built into the object. So each of the elements in the array stores data, but there's also other data stored about the array in the array object. One of these fields is a length field. This is not something we can change, but it is something we can read. So perhaps we asked the user, how many values do you want to enter? And they said 7. So we took the integer value that they typed in and created an array with that many elements. But now we need to loop through this array of however many elements, and we don't actually know how many elements they have chosen to have. One way we could go about that is by accessing this length field. So we could say in a for loop, for, and then our count variable I, we're initializing it to 0, and then our test would be I less than number.length. So for each index, starting at 0, up to number.length minus 1, we'll print out the elements of the array. So this would print out the entire array regardless of what size it was. Now notice the syntax, this is not an error. It's .length without any parentheses on the end. Length, when we're dealing with arrays, the .length is not a method. It's a field. So this is not a method call. This is accessing a field, and a field is somewhere that information is stored in an object. So we said objects have both data and behaviors. So this is data, not a behavior. In a string, when we use the .length method, This is a behavior. This is a method that we are calling that returns the length of the string. However, when we say number.length, we are looking at data stored in the object. This data that's stored in the object is called a field. It's stored in a field, and the name of that field is length, and it's read-only. So let's say that you created an array of length 10, and you said, oh wait, no, I actually need it to be 12. Well, you would have to make a new array object because this array length is read-only and cannot change. In general, it's better to use the array.length field than it is to code an integer literal. Like let's say that you said, well, I know how long I'm going to make my array. It's length 10. So when you code your for loop, you say from 0 to 10, print out all the elements. Yeah, that'll work. But what if for some reason you go back in your code and you change it so that when you make your array, you make it with length 12? Well, now you're going to have to go through your program and figure out what each of the integer literals, every place you typed in a 10, are you talking about your array, or is it just some other spurious 10 you happen to have typed in? So rather than having to figure out and adjust your integer literals in a program, you can use the number.length field to reference the length of the array in your program. This is sort of like creating a class constant instead of going through and typing in 0.05 when we were doing our calculator program for the total bill at a restaurant. Rather than having to go through and change it everywhere, if we changed the tax amount, it was better to create a class constant. Here, it would be better to use the number.length field in the number array. One of the reasons we're bringing this up about using the array.length field is because being aware of the array length is very important anytime you're reading or writing to the array, from or to the array. Because if you attempt to access element 10 in an array that only has index through 9, so this array does have 10 elements, however, it starts at element 0 and counts to element 9. So if you attempted to access element 10, that does not exist. And that will cause the program to throw an array index out of bounds exception. And that's going to crash the program. So if we in code create an array with 10 locations called data, and we access element 0 and element 9, we're good. But if we access element -1, there is no element -1. That's not a valid array index, and therefore this will crash the program. Just the same, if we attempt to access element 10, then that will also crash the program. Here's a mini exercise to test your comprehension thus far. If we had an array called number, how might we access the last element of this array without knowing how long it is? How might we access the middle element? Write a statement to access the last element of an array in which you do not know the length of the array. Write a statement to access the middle element of an array, and in this case, if there's an even number of elements, then the middle element would be the element to the left of center. So write a statement to access the middle element of an array without knowing the length. To access the very last element, it's fairly straightforward. Our array is called number, so we would say number and then open bracket, which means we are going to give it an index, and the index we are going to give it is the number.length field -1. This always points to the last element. The reason is because the length is the total number of elements in the array, And the maximum index, or the last index, is always one less than the length. How will we access the middle? Well, we're going to make use of the number.length field again, and we're going to do the very same thing. We're going to find the last index and then just divide by 2. And this is integer division, so it's going to yield an integer. If number.length is odd, which means there's an odd number of elements, that means that there is going to be an exact center element. So when we say number.length and it yields an odd number and we subtract 1, that will be an even number. So let's say we had an array with 3 elements. But like we said, we didn't know beforehand that it only had 3 elements, but it had 3 elements. Locations 0, 1, and 2. Number.length is going to be 3. So obviously the center element is 1, but number.length minus 1 is 2. 2 divided by 2 is 1. So we're taking the length, and if it's odd, then that's going to be, when we subtract 1, that's going to be an even number, and when we divide by 2, that'll be the precise center. However, if this were a 4-element array, that means there are 4 total elements, then the last index is going to be 3, and the length is going to be 4. So 4 minus 1 is going to be 3. When we divide by 2, that's technically 1.5, but remember, when we're doing integer division, we truncate. So 1.5 becomes 1. So this would be our center element. So anytime you want to find the center element of an array, you should use this formula. As we have shown, the formula works for both odd and even length arrays. And if there is an even number of elements, then the middle is considered to be left of center. So let's look at this code that should find the largest even integer in a given array. So the first statement creates an integer array called list, and then we are initializing it with these values. This is another way to initialize an array. Just like we can use double quotes and type in a string to initialize a string, we can use curly braces and declare each of the values that we want in an array. So this would go into element 0, element 1, element 2, 3, 4, 5, 6, 7, 8, 9. So this would automatically create a new array object with length 10 and populate the array with these values. So now let's look at the code to be able to find the largest even integer in this list array. So we need to initialize a variable called largest even to keep track of what our current largest is. And then we need to process each element in our list array. To do that, we will declare a for loop, and we will start it at 0. So our count variable I we will initialize to 0. Our test, we will say, is I less than list.length. So this will process each element of the array independently, or individually. And then as update, we're just going to increment I at the end of each loop. So inside this loop, all we're going to do is test to see if the current element of the array, when modded by 2, is equal to 0. So this is a test to see if element I in the list array is even. So if element I is even and element I is larger than largest even, we will assign largest even the value stored in element I. We do this for each element in the array, and when we're done, we print out the largest, which is 6. So a couple of takeaways from this code. First of all, notice this other approach to initializing and creating an array. Remember that we can use the mod by 2 equals 0 to test if a number is even. And remember that when you're processing an array, to use the list.length field rather than an integer literal so that your code is more modular. Here's the final mini exercise. Pause the video and see if you can figure out what the final contents of array A will be. So when we declare array A, we are giving it 7 elements, so element 0 through 6, and they are initialized with the values in curly braces. So initially, we have 1, 7, 5, 6, 4, 14, and 11. Then we have a for loop that is going to process from 0 through a.length minus 1. So notice we're adjusting this because inside of our loop we're going to access I plus 1. So we're going to access 1 further than the current array count. So if we're going to do that, we have to decrement our test, because if we were to allow this loop to process all the way to I less than a dot length, then when a took on the value 6, when I took on the value 6, inside this loop we would attempt to access 6 plus 1, which is 7. And there is no element 7, and this would be a runtime error. So we had to adjust this so that we would stop processing at a.length minus 1, which would be, so 7 minus 1 is 6. So I will only be able to take on the values 0 through 5, because when it takes on the value 6, it'll jump up here and say, is 6 less than 6? No. Exit the loop. So that's an important detail because we are accessing I plus 1. So now let's look at the effect of this loop now that we understand the index bounds. So if a element I is greater than a element I plus 1, so if element I is greater than the next element, then we are going to multiply the next element by 2 and store that value in the next element. So if we're looking at element 0, we'll say, is 1 greater than the next element, which is 7? The answer there is no. So we will not execute this interior in this if statement. And we'll jump to the end of the for loop. We will go back and test. So is 1 less than 6? Yes. We updated, right? At the end of the loop, we did our update. So we incremented from 0 to 1. So is 1 less than 6? Yes. So is element 1 greater than element 2? Is 7 greater than 5? Yes. So we are going to store element 2 times 2 into element 2. So whatever the value currently is in element 2, multiply it by 2. So 5 times 2 is 10. Then we assign that value back into element 2 of array A. So now this is 10. Okay, we have finished all the statements in the if statement. We have finished all the statements in the for loop. So therefore, we will update. I becomes 2. Test is 2 less than 6. Yes. So we begin to execute the statements in the for loop. If element 2 is greater than element 3, so is 10 greater than 6? Yes. So we are going to take the value stored in element 3, which is 6, multiply by 2, that's 12, and store it back in element 3. So this becomes 12. All right, we've executed all these statements, executed all the statements in the for loop. Update. So update I, that becomes 3. Is 3 less than 6? Yes. Is element 3 greater than element 4? So element 3 is 12. Element 4 is 4. So yes, element 3 is greater than element 4. Therefore, we multiply the contents of element 4 by 2 and store it in element 4. So we are doubling element 4, becomes 8. When we're done, we update. So I becomes 4. Is 4 less than 6? Yes. Is element 4 greater than element 5? Element 4 is 8. Element 5 is 14. No. So we don't do the statements. We're at the end of the for loop. Update. I takes on the value 5. Is 5 less than 6? Yes. Is element 5 greater than element 6? So is 14 greater than is 14 greater than 11? Yes. So therefore we will double element 6 and store it in element 6. So 11 becomes 22. So the answer you should have found was element 0 had the value 1 because we initialized it to 1 and we didn't change it. Element 1 had the value 7 because we initialized it to 7 and didn't change it. Element 2, we doubled from 5 to 10. Element 3, we doubled from 6 to 12. Element 4, we doubled from 4 to 8. Element 5, we did not change, so it was left the initialized value 14. And element 6, we doubled from 11 to 22.